Okay, the weight of a satellite in a circular orbit around the Earth is half of its weight on the surface of the Earth. The radius of Earth is 6.38 exponent 6 meter, while masses of satellite and Earth are 800 kilogram and 5.98 exponent 24 kilogram. Determine the altitude of the satellite in its orbit. Okay, so this question is about satellite. Is it about satellite? However, so is it we going to use this formula for satellite, velocity of satellite, or this period of satellite? Period is 1 day. Is it going to use this formula? Look carefully. This one he focused on. Actually, the keyword here is about the weight. It's the weight. Understand or not? Weight in a circular orbit around the is half of the weight on the surface of Earth. So it's about the weight. You see that? One is in the orbit, weight on the orbit. Another one is weight on the surface. Okay. We can put as weight of satellite on the surface is W1, weight of satellite at the circular orbit as W2. So we have two conditions here. Understand? So we can say that he said the weight of satellite at the orbit is half. It's half of the. So it is half of the weight on the surface. So we can put like this. We can put as the weight in the circular orbit is actually half of the weight on the surface of Earth. Half of the surface of Earth. Weight on the surface of Earth. And this one is the radius of Earth. Okay, write that down. We have the radius of Earth. This is the, okay, write it down over here. This is the radius of Earth. And you also give us the mass of satellite and mass of Earth. Okay, so this is the mass of satellite. This is the mass of Earth. Okay, now we need to find altitude. Altitude, so is h, or this is actually altitude is called height. Yeah, sometimes you call it height, or sometimes you call it altitude, or sometimes you call it we call it what? Distance from surface. Distance from surface of Earth. Yeah, that's altitude from surface. We need to find h. Okay, so we need to find h. Okay, so do you think we need to use a formula about period or velocity? No. Yeah, because here didn't mention about period, right? It mentioned about weight. The keyword is about weight. So weight, what is about weight? Why the satellite has weight? Why satellite has weight? Because of gravitational force, because the Earth is pulling on satellite, satellite also pulling on Earth, Earth also pulling on satellite. That's why we have weight. So we use the formula of gravitational force. So we assume this one like our satellite, this is like our Earth. Understand? So in between them, they are pulling each other. They are pulling each other. That's why the satellite has weight. It has weight because it has gravitational force. So the weight is actually the gravitational force. This is actually the weight. The gravitational force actually is the weight. Understand? Gravitational force is actually the weight. But the weight at the circular orbit is smaller, or half of the weight on the surface. Because as we are going further and further away, if our r increases, you see, if our r increases, our gravitational force or the weight of satellite will decrease. That's why it becomes half. Understand? When the satellite going further and further away, this gravitational force become weaker and weaker, because when r increase, gravitational force decrease, the weight decrease. So we are going to use this formula. Gravitational force equal to gmm over r square. Gravitational force, not the satellite formula. Understand? Not the satellite formula. It's about the weight. It's about the weight. So weight is about gravitational force. Weight is about gravitational force. So we're going to use this gmm over r square. We have square. Remember vector. We have r square. Okay. So this is the mass of satellite, and this is the mass of Earth, this is the mass of satellite, and this is the distance between center to center, center of Earth and center of satellite. Okay. So so we're going to use that. Look carefully. I want you to look carefully. Maybe I want to draw again. Draw like this. This is the Earth. This is the mass of, this is the Earth, okay, and this is the satellite. So r is the one is on the surface, one is on the, like that, yeah. So we can say the r, yeah, talking about the r, talking about the r, this is the r. Okay, so on the surface, if on the surface our r is radius of Earth, understand that? Our r is radius of Earth, but if on the circular orbit, yeah, it has the orbit, right? It has the orbit. If on the circular orbit, the r is, what is the r? What is the r? It is radius of Earth and h, right or not? So it is r equal to radius of Earth plus h for satellite in orbit. This is at the orbit. On the surface, the distance is just radius of Earth, but at the orbit is radius of Earth plus h, plus the altitude. This is what we're going to find. This one, this altitude. This is the altitude. Yeah, from surface to orbit. That's the altitude. We are going to find this value. Okay. Now, okay, let's do it. So the gravitational force is the weight. So now, okay, talking about this one. Okay. This is at the, okay. This one is the orbit. This is the orbit one, the weight at the orbit. This is the weight at the surface. Remember? This is the weight at the orbit. Okay. Weight at the orbit. Maybe we write down one by one first lah. Yeah. Okay. So we can write down one by one. On the surface. First we write down on the surface. The gravitational force is the formula, gravitational force equal to gmm over r square. Okay. On the surface, the weight is w1. Okay, w1, and then g mass of Earth, mass of satellite over, you see, if on the surface, the gravitational force, the gravitational force is w1. Okay, w1, and the distance is just radius of Earth. Just radius of Earth. Put that as radius of Earth square. Okay, that's the surface. Now, okay, make a divider. Now on the orbit, so use back the formula. Fg, gravitational force, equal to gmm, okay, over r square. Okay, so in the orbit, the gravitational force is w2. Over here is w2. Okay, that's the gravitational force, w2. So w2, put that w2, w2 equal to G mass of Earth, mass of satellite over these R at the orbit. The R is radius of Earth plus H. Understand? Radius of Earth plus H. This one. So radius of Earth plus H. Like that. Yeah. So we already have W1 and W2. Okay. So what's next? What's next? Put these two formula into this one, into this formula. Okay. So continue. Okay. Continue. So this one continue below. And okay, put the W2, the orbit one, this one, into here. G mass of Earth, mass of satellite over radius of Earth plus H square. Okay, and then equal to half of what? Half of GMM, same thing, yeah. Mass of the weight at the surface, weight of surface is GMM over RE square, radius of Earth. Radius of Earth square. Okay. So substitute inside, and looks like we no need to use. This is the mass of Earth. You see that? This is the mass of Earth, mass of satellite, mass of Earth, mass of satellite. Looks like they are cancelling each other. Even though he gives us the mass of satellite and mass of Earth, but we are not using them because they are being cancelled out. They are being cancelled out. You see that? So it's easy, this question. We just need the radius of Earth. We just need the radius of Earth, which is 6.38 exponent 6. Okay. So it looks like the top edit has been cancelled. We want to find the H here. We want to find the H here. Okay, the altitude. This is what we want to find. The altitude. Yeah, this is the altitude we want to find, the H. Understand? So, okay, so just substitute the radius of Earth. Okay. What's the value? We need to cross multiply first. Okay, I mean, this one just go to the top. These two go to the top. Radius of Earth square also go to the top. So it becomes this formula. It becomes this formula where 2 RE square, isn't it? Go to the top. That means just invert the fraction. We got this. And then we don't want the square, isn't it? What are you going to do with the square? Just you know, this square root both side. Okay, square root both side. Okay, never mind. This one we not going to expand. Okay, this one become like this, isn't it? Okay. So this one go below. It go below. Okay, it go below. And 2. So we square root. We square root both sides. We want to remove the square. So this one also square root. But remember, we have positive negative, right? When we square root both sides, when we square root both sides, remember to add the positive negative. Add the positive negative. So okay. So here we have no more square. So it becomes like. So radius of Earth is 638 exponent 6, 6386. Okay, write that down. Okay. Never mind. I think just maintain first to simplify the work. So become this one. So what is this value? Never mind. Just write that down first. Plus minus 2. Okay. So and then we have just multiply to the top. Multiply to the top. So radius of Earth plus H is you know, plus minus 2. Apply this one. Okay. So what is H? H would be you know, plus minus 2. And then become minus. Okay, so let's find out the H. Let's find out the h. So we have two possibility of value. We have two possibility. One is sub2 radius of Earth minus RE. Okay. Another one is h negative sub2 radius of Earth minus RE. So which one? Is it both correct? Is it both correct? Let's check first. Okay, let's check first. So, okay, we're going to substitute the radius of Earth. What's the value? 6.38 exponent 6. Okay, let's substitute. Sub2, and then we have we can actually factorize this, right? We can factor this out. Okay, we can factor out the common, right? This one becomes sub2 minus 1, right? Just now the radius of Earth is 6.38 exponent 6, right? Exponent 6, isn't it? 6.38 exponent 6. Okay. And then here we have sub2 minus 1. Calculate. And then this one also we can factor out. We can factor out, radius Earth. This one becomes what? Becomes negative sub2 minus 1, isn't it? Good. And so this will become 6.38 exponent 6 exponent 6. This one is okay, negative sub2 minus 1. Okay, so what's the value? Okay, let's calculate. Okay, so let's calculate sub2 and minus 1, and then multiply by 6.38 exponent 6. Okay, the first one we got 2.64 exponent 6, yeah, exponent 6 meter, yeah. Now this is exponent 6, and then the next one is negative 2 minus 1. Then I multiply 6.38 exponent 6. This one we get h equal to negative. My God, this one got negative value. So this one can be ignored because it's not possible to have height negative. Yeah, height negative means what? Means sink into the soil, sink into the ground. No, yeah. So this one can be ignored because it's negative value. Exponent 367. So this one can be disregarded because not possible to have negative value. Yeah. So this one can be ignored. Ignored because this one cannot have negative. Yeah, cannot have negative. Yeah, cannot have negative. This one positive value. Okay, correct. So this is the height 2.64 exponent 6. Is that correct? The answer? Yes, that's the answer. That's the height. 2.64 exponent 6, which is A. That's the answer. That's the answer. Okay? Understand? I hope you understand. Enjoy. So cannot have negative value. Yeah, can have positive value. So the negative one can be ignored. So the answer is positive 2646. 2646. That's correct. Okay. So that's all for these questions. It's about the weight. Weight is about the gravitational force. That's all you have to remember. Weight, gravitational force. The weight is the gravitational force. So we're going to use this formula, Fg equal to gmm over r square, to solve the question. That's all. Yeah. At the surface, if at the surface it's just radius of Earth, but if at the altitude, at the orbit, we have radius of Earth plus altitude. Okay. Plus h here. And don't forget you have the radius of Earth. You need to plus with radius of Earth because we are going to the center, not just to the surface. Okay, to the center, center to center. Okay, r is the distance from center to center, so we need to include the radius of Earth. Okay, for this case, it's a satellite, so we don't have radius of satellite. No, I just have radius of Earth. Okay, so that's all for this question. Thank you and bye bye.